Hello and welcome back to module number 9. In this module we are going to talk about graphics in R, and usually we define the graphics in R into three components: basic graphics that R can produce without any additional packages, and the other two, Lattice and ggplot2, is add-on package that you need to run the package in order for you to generate the visualization. But before we will go into those three elements of producing graphics in visualization, to those who in my visual analytic class I cover that, so I thought it's going to be just a general review for you. And then the last comment that I have is that for the students who for all the students who took the quiz on Monday morning, I will post the answer for the quiz, and I'll go over the quiz and what I expected to see, and I hope it will make more sense. Your job, again, as I repeated again, is to ask questions. Okay, so basic to what we aim to cover in this class is, or module, is the graphics in R. So Wickerman points out in his book that R graphic packages that are based on graphic system has a pen on a paper design. Basically, he says that the basic way it works, it's a set of a pointing area and then you add the element to it. Once you have the element to the plot, it cannot be removed, so it's a good idea to keep a little script going on so you can retweet the graphic itself. So this is a sidekick to our discussion about graphics in R. So the basic command to use to produce plot in R is plot and the command itself. So there's two arguments that goes into this command. First of all, it's the x and the y coordinates, and then you can provide another vector of values which is used as the y coordinate, and it is a plot against the index value of the vector. So type of a plot, and I lay out all the 9 basic ways for the R to plot a set of points, and to use one of them, define the type of argument one of those ways. Example, the P point, the I for a line, you can use both, or the C, the B as conjunction segment, or over plot, or histogram, or stair, and or none of the above. So those are the structure of the plot without any idea, with the idea of what we're trying to achieve in order for us to match the statistical analysis that we are trying to do. So point types. There are 25 different pointing points that can be used to define the argument, which is the pitch, which is, I believe, stands for point character. So point 21 through point 25 are multicolor points. So you can define, or you can fill colors with the BG, which stands for the background. So those are the points that you can use in your visualization. And in addition to that, of course, you can define the lines, the type of lines you are looking for. A solid line or any other type of line throughout. And also the width and the size. And again, this is the components of what R provides you better than any other software, the ability to set yourself or design yourself what type of points you want to do. In addition, there is the issue of colors. So R has 8 default colors which can be assigned to a point or line by passing a numerical value, 1 to 8, 2 colors. However, R also has 657 name scalars that you can call upon by passing the name of the color to call. So the idea here is you can see the name type colors and you will see all the 659 colors that the R provides. We also have the idea of color patterns, which is there are usually, and again, I'm sorry to disturb, but I'm sorry to cut, but usually Microsoft Excel does that all the time. So in this case, again, R provides us more ability to control these settings without ability to, unlike Excel, that just give it to us as it is. In this case, rainbow or heat or gray allowed us to play with the colors or to add additional elements. If you give any of those functions a number, for example n, it will return that number of colors from the palette as a vector. So I want you to remember that. There are also some arguments that can pass as well, such as the alpha, which is the control transparency. They all share the same help page, so inspect that for more details. I will not go to it because I have the objective to finish it. So the gray palette is different, however. It takes a vector of the values between 0 and 1 instead. So 0 is return black and 1 return white. So the values in between return the gray or the percent of the gray into it. So this is the issue of the colors or the palettes that I talked about. In the rainbow, this is the 12 colors that they provide, and so on and so on. So at the gray, as you can see, it goes from the black to white. So when we are building a plot, example cars, and I have a container that holds 5 values of cars, and if I will do that, it will show the following. So if I will say plot cars type 0, color blue, and I will say I will give it a title, I will give it red, and I will do format, it will produce me the visualization I want to. But this is not, as I said before, and I repeated the same thing into my visual analytic. Is this good enough? No, it is not. It doesn't make it more transparent. It doesn't show anything that you want to tell the user that already saw that type of visualization. And the idea is, again, the visualization from my point of view is it needs to tell an additional narrative to the story that you are trying to do in analytics or in statistics. And the idea here is not to build in a support, but to give another dimension to it. So good thing it's easy to customize because you are going to do it all the time based on the graphics that you're going to produce. Okay, so a little bit about lattice packaging R. And the idea comes from implementation of a Cleveland book in 1993 and called Visualizing Data. And the idea of the Shankar, who developed this package, was introduce the idea of 3D into R, and to do that by using advanced statistical analysis to do that. So it is high-level functions that not only can print but also plot everything. So in this case, what you're going to call or see in this package is that a class called Trails, which can be printed or plotted. In this case, I want you to see that functions that this package creates, or example of this, just to understand the issue of what I have been purchasing or trying to tell you again and again about functions. See how the function in Lattice graphics are customized and see how it affects the overall. It also has an add-on package. So the advantage of this package is that it can display multi-panel conditioning, it can convey additional information, and add some useful data summarize, which is a linear fit or smoother or minimal folds. That is argument that can be very useful or powerful when you are trying to make a case for your analysis. So the issue of the package or the functions that what I want you to hear. So you install the package, you click on the library of the Lattice, and now start the issue of the arguments. In this case, it's called XPplot, and it gives you the idea of there is two conditions, Lattice and log, and the data is quakes, and we are trying to apply that. So the quakes is the database we are using in this set. And this is how it will display. So it will display something like that, where we do not have a lot of control over the colors, but we do have the idea of this is a very unusual visualization, and someone probably needs extra glasses like myself to see what is it entail. So you can do the following commands in the same thing, and you can do dplot, and you go into to print it in order for you to see the same effect and to see where the arguments is laying out in order for you to do so. So why Lattice? Paul Merrill, who wrote the books about R graphics, give 3 reasons to use that. Usually, he says, they usually look better, which is a very powerful argument. It is also extension to the powerful ways that R works, and the resulting output can be edited or saved for later use, and something that is really important. So, how do we plot the formula in this package? So the first argument that we saw in the first example is that we have a formula. And by doing that, it is basically x and y multiplied by y, and you are giving here an argument that are becoming a function that every visualization that go through this package has to go through in order for it to survive. So, example of histogram. Again, we are starting with the histogram, which is the core for histogram, but in this case I'm going to do the find of the height and the voice part and the data, and in this case it will present something like that. And again, this is, I want you to see the arguments that we are building here. So the panel is the function, the panel of the histogram, the panel of the methodology and the distribution, and everything is defined in order for us to generate something like that. Last example with the Lattice is again wireframe. And the idea again is that I'm giving specific values in order for me to have a light source in order for me to shine. So in this case, it's a 3-dimensional or 4-dimensional, wherever you call it, and it gives us the ability to present the row, the column, and the velocity of this data in order to apply. In my visual analytics, one of the things that the authors that we often read, Stephen Yu, complains that please do not use 3D or 4Ds in visualization, because the user do not see all the points in the visualization when you are presenting. We do not know how good is his screen. We do not know how well he be able to see. So those concerns are part of the equation. However, this is a beautiful capture of the data. This is a capture, very nice indication that what the power of R can do. So we need to go to the next level, and the next level is the foundation of ggplot2. ggplot2 was created by Handley Wickerman. Wickerman, he is now the CTO of RStudio, and he has a personal website. He created, he works, and he also publish, and he also provide us, and this is something that is really important for you to understand. Even though he is a superstar in any sense or any category, he has a GitHub where he documents all the procedure and all the functions that he wrote to generate the ggplot2. And why is it important? Because it gives us as users and our community members the ability to look at what he does and see how he wrote the functions in order for us to apply. That's why your bold professor insists that you will have a GitHub. Why? Because the GitHub is where you post your code, you post your work, and share the post able and receive comments if you have comments from users. So the structure, unlike the two other, the basic or the letters package, there's a structure to ggplot2. The structure consists of several elements that is part of the visual grammar that it aims to capture. There is the aesthetic, there is the geometrics, there is the statistics, the scale, and other elements that the package provide. Coordinate system, pathing, positioning, data, annotation, and all those together allowed us to produce something that is really special in that it provides us the idea of, I'm looking for example, something like that. Okay, so I'm going back to my notes about the structure and about what does it entail. So the aesthetics. The plots convey information through various aspects of aesthetic. Some aesthetics of the plot are the X position, the Y position, the size of the element, the shape of the element, and the color of the element. The geometrics is the point, the line segment, the bar, and the text. The scale in grammar of graphic is the control of the mapping from the data aspect of the aesthetic. So in ggplot2, we often use color filling scale to determine the automatically. So we use custom color schema so we can take control of the mapping of the country, for example, factory into fill color, so it will give us more advanced visualization out of it. Some of those geometrics have its own particular aesthetics. Example, you can determine the point shape, the point size, the line, you can determine the line type and the line weight. The bar, you can determine the Y maximum or the X maximum. You can determine the fill colors and you can outline the colors, and also the text label values. So this is again, I'm taking the notation from MTCars. You have to install ggplot. I think if you are running the latest version of RStudio, it's already. So in this case, I'm calling ggplot2. I'm using MTCars as my set, and I'm using the aesthetic, which is 2 points, WT and MPG. But what I'm doing now, I'm adding the geo as a points. So the idea here is that this is what it will display. But I can also add another layer to this visualization, which other platforms do not allow us to do. So in this case, especially Microsoft Excel. So in this case, I can have x-intercept equal 5 in order for me to have a line saying, hey, this is the line of intercept. I want you to take or to look at that in order for you to understand what does it entail. So again, this is the points that I was trying to make with regard to the aesthetic and the geometrics. The code behind it, and I lay out for you, and the mapping, the data, other argument based on a layer, all of that is laid out for you so you will have a better sense or better idea what does it entail. One of the things that I want to emphasize or re-emphasize, the show legend. And this is, should this layer be included in the legends? The answer is depend. It depends. False never includes and true also includes. So again, it depends on you deciding how you want it. What I'm asking from you is that you will play with it to see if it fits to your for your own example, for your own work. So next example, again, I'm going to create a data frame from x to 1 to 10. And the idea here is that I'm going to use GeoLine in order for me to do that. And this is my data analysis aspect, and this is what it entails. So this is what it will give me out of it. So what makes the ggplot2 so unique? First of all, I don't know if you are familiar, but you should be familiar with Adobe Photoshop. It is based on the idea that Adobe Photoshop, that was so popular and still is popular as one of the foundation of visual design, is that it allowed us to create layer by layer. The same techniques go here. The ggplot2 allowed us to create layer by layer. All the ggplots work with the function of the ggplot2. So we have the layer of the data, we have a layer of the aesthetics, and we have a layer of the geometrics in order for us to create something that is, in my eyes, beautiful. So more example of ggplot2. I highly recommend that you visit this website. One of the reasons that I am also so like this website, you will click on docs on ggplot2, and you will see the layout what he gives. So he gives you the commands, he gives you functions that Handley wrote, and he gives you what is it entail in order for you to do that. So everything is break down and give you the scale, what is it entail, and all of it is part of what he is trying to achieve in order for you to apply and to present the example that I talked to with regard to specific. So again, arguments, how to edit, how to convert from the scale in the background or the opposite, and how to apply to it. The arguments, everything is laid out for you. So again, I know it will require you time to configure that, but I highly recommend that you will do that. I'm going to take you to the next step, which is the ggplot and maps. I will illustrate to you very simple map as illustrated in my own book in page 295. It is called the package that I use, it's called Reshape to create this map. So in this case, I'm calling the library of ggplot2. I'm going to say the crimes, and I'm going to use the library, the package called Reshape, and I'm going to build my ggplot2. And as you can see, the ggplot2, when we are starting to code, I created if condition, but then I created the ggplot2 with all the components that I was talking about: the aesthetic, the geometrics, the extension of the limits, and the idea of what it entails in order for me to produce something like that. This code will be posted on the canvas, so you will not have the idea of the trouble to find it. So you have the murder, the assault, the urban population, and the rape. And again, this is a powerful illustration of how we are applying. So again, visualization is an important part in every R conference that has been taking place or been presented. The visualization was the key element, the key component. Everyone needs to show how their package can be converted into visualization or employ other visual packages into it. The foundation of the visualization comes from Wilkinson about the scale of visual grammar and how to perceive it in graphics. So overall, it is the idea that we are trying to make more sense with regard to visual, regard to R, and the statistical analysis in order for us to do that. So this is it. I'll post more example in the canvas and links, and I hope you enjoy it. Until next time, have fun.